Okay, so welcome back, and now we're going to do another one. So again, we've got this quadratic form in sine theta, and so now what we're going to do is factor. So again, we can factor by decomposition. So I'm going to decompose the middle term by using the AC method. So 2 times 1 is 2, right? And so this is positive, which means we're going to have opposite signs. And since this is negative, then we know the larger factor is negative, right? Or excuse me, rewind. This is positive, which means they're going to be the same sign. That's what I meant to say. Positive, and they're both negative because this is negative. So the obvious factors are going to be -2 and -1. So now these add up to -3, and they multiply to +2. And so therefore, I'm going to rewrite the middle term with these two factors. So it's going to be 2 sine squared theta minus 2 sine theta minus sine theta plus 1 equals 0. And so now I'm going to do factor by grouping. So I'm going to group these two, and I'm going to change this to a plus negative and group these two. And so now what happens? I'm going to factor out the greatest common factor here, which is going to be 2 sine theta. So I'm going to have 2 sine theta times what's left over, which is going to be sine theta minus 1. And over here, I'm going to factor out, so over here, I'm going to factor out a -1. So I'm going to have a -1, and what's going to be left over is sine theta minus 1. Okay, and now I've got a common factor again. So I've got two terms with another common factor. So I'm going to factor out again. So I'm going to get sine theta minus 1. And what's left over? I'm going to be left over with 2 sine theta minus 1 is equal to 0. And now, guess what? That tells me, using the zero product principle, sine theta minus 1 is equal to 0, or 2 sine theta minus 1 is equal to 0, which tells me that sine theta equals 1, or sine theta equals 1/2. Now, guess what? Again, look at my range, right? My domain here for theta. So where is theta going to be equal to 1? Well, there's only one angle on this interval that sine of theta is equal to 1, and that's going to be theta equal to pi over 2. Okay? Or, okay, so here's the or. Theta, where's theta going to be equal to 1/2? Okay, in this, again, on this domain, on that interval, theta is going to be equal to 1/2 in 2 locations. Positive, right? So sine is positive in the first and second quadrant. Okay, and so that means that theta in the first and second quadrant is what? Well, in the first quadrant, again, this is 1/2, so again, if we're in the first quadrant, we're looking at theta and its opposite over hypotenuse, which again gives us a 30, 60, 90 triangle, which means theta is 30 degrees here. So the first angle is going to be pi over 6, because it's in the first quadrant. Now, the next one is in the second quadrant, because sine is also positive in the second quadrant. So that means it's going to be 1/6 pi less than pi. Okay, which means it's going to be 5 pi over 6. And those are the other two angles. So these are the solutions, okay, to this quadratic equation. So theta will either be pi over 2, or pi over 6, or 5 pi over 6. And they're all in the domain. Have a great day.